Hey, what's going on everybody? Welcome to your micro series on cryptography, and we're going to be talking about some of the most common encryption algorithms, how they work in the different categories of algorithms. We're also going to be touching on things such as hashing, and overall we're just going to basically learn the basics of various different things in the field of cryptography. By the end, you're probably not going to be an expert like me, but you should have a pretty good introduction. Pluralsight, it's one of the first learning platforms I used as a software developer. You can get a completely free trial and start learning by following a path on pretty much anything. The learning paths combine numerous courses giving you the step-by-step path to reach your goals. Or you can find individual courses on pretty much anything. Maybe you want a class on cryptography, security, Python programming, networking, maybe Java, you name it, and they probably have it. I can genuinely say that Pluralsight helped me advance my skills and my career. I'll leave a referral link in the description, go check it out. Where do we even get started? Well, I guess we'll just jump in. Now, if you didn't catch it when I said I was an expert, I was kind of teasing. To preface, encryption is kind of insane, and honestly, at some point I was studying this, and I was just like, oh, the more I study, the less I know, and at some point I just had to slap myself and say, yo, shut up and just do the videos. So with that prefix, hopefully we can go through this getting a pretty good introduction, but I do warn you that this stuff does get very deep and we're just going to be scratching the surface of some of the most common things. So to start, what is encryption? Well, not that I got all my information from Wikipedia or anything. Encryption is the process of encoding a message so that only authorized parties can access it. In other words, let's say I'm trying to send you a message. I want you to be able to understand it, but I don't want anybody else to understand it. And this is essential when we're dealing with computers because computers talk to each other and we don't want people to be able to intercept messages and read what things are saying. So anytime messages like emails are encrypted or files are encrypted, only you or the person you intend to access it can read that information. So that is the basis of encryption. Now you don't have to be a software developer to get a lot of information from this series, but we are going to talk about it in that point of view because a lot of this stuff does really deal with computers and programming and networking and all of that stuff. So one thing you need to understand is what is a function. And a function is something that takes an input, processes it, and gives an output. This is used for everything in programming and getting computers to do stuff. We can define a section of code, and that section of code is called a function. And a lot of these encryption algorithms will be built into a function, which you can just think of as passing a message in, it does its stuff, and then we get some stuff on the outside which you can't read. That would be an encryption function, or what you would call a cipher. So a cipher is a function used to encrypt a message, and the output of that cipher is called cipher text. So whenever you hear people talking about cipher text, it's just a fancy word to say an encrypted message. So we're going to go through an example of what this might look like using some Java code. Now, if you're using a different programming language, not a problem. It's really super simple. All right, so here I have some Java code, and we're just gonna go through this one line at a time. Let's say there's this girl you got a crush on in class or something, and you're trying to talk with her, but you're trying to keep it super secret. So if you get caught and you have to go up to the front of class and read it, no one's gonna know what you're talking about. All right, so you write this message and you say you're cute. And we don't need this comment here, that's just from the generated code. And then what we do is we encrypt this message. Once it's encrypted, we send it to the person we're trying to send it to. And let's just say by chance, someone grabs that letter. So that would be the intercept. And when they try to read this, they're not going to understand what it says. But then let's say that message eventually gets to the person you're intending it to go to, and that person is able to decrypt this message. Then they can understand the original input. So just to see this, we're going to take this message and we're going to print it when it's encrypted. We're going to then decrypt it and print it after that. So we'll run this, and you can see this is the encrypted version of that message, and then once you decrypt it, we get that original message. Now the thing here that you should understand is that encryption can often be abstracted away from our brain as long as we have a trustworthy encryption algorithm. So there's lots of different encryption algorithms. For example, you may have heard of AES or RSA, And let's just say in theory that these are trustworthy and no one's been able to crack them or figure out how to break them, then you don't need to understand the inner workings to use them. In this situation, I'm using this encrypt function, but you have no idea what the code is. And that's the concept of an abstraction. We don't have to worry about what that code is because we know it works. But just in this case, I'm going to show you that code. So if you go down to my function, we'll take a look at the encrypt function. There's also a decrypt function. They're almost exactly the same. So I think you could just make one function that does both purposes with just like slight variations in the code. But in this situation, we can see it clearly using these two functions. So all this really does is takes the message and it increments each character by 1. And the way I did that was a little weird just because of the way Java works here. So I started with a string that was empty, and then I went through each character and incremented it by 1. So A becomes B, B becomes C, and so forth. So if you take a look at the encrypted message, Y became a Z, O became a P, U became a V. So once you understand how that encryption works, super easy to understand. And in that situation, this encryption algorithm would have been cracked and would no longer have been useful. We can do different things to change how it works. So for example, we could increase the amount, the number of characters to shift. So instead of 1, we could increase it 5, and then we would have to also decrease it 5. And now when we run it, the encrypted message is different, and someone might intercept this and try to decrease it by 1 and realize the message still doesn't make sense. But this is still so simple that pretty much it's useless for anything serious, anything beyond sending a little love note to someone across the room. Now another thing you could do with this is parameterize it. So instead of having the 5 hard-coded in here, you could have an integer called shift. And then instead of saying +5, we could say plus shift and minus shift. And then when we call this method, all we would have to do is pass in the amount we want to shift it. So when we encrypt it, we shift it 5, and then we decrypt it and we shift it 5. Sorry, it's kind of a tongue twister there. So that's another way you could write this code. Again, we're not really worrying about how to write this code, but that might make it a little bit more versatile if you're changing the amount you're shifting numerous times. So that is the simplest example of an encryption algorithm, and this concept actually has a name. It's called a Caesar cipher, and I think it has to do with like history stuff with like Caesar. I'm literally terrible at history. So Julius Caesar used it in his private correspondence. In other words, he was sending love notes to people around his kingdom. He didn't want anyone to know about it. And you can see a visual representation of this right here, where an E becomes a B, an F becomes a C. It's just shifted over a couple characters, super simple. So to really conclude the message here that I'm trying to deliver to you guys, it's very easy to take a message and encrypt it. But if we don't have the decryption algorithm, we don't know how to get it back, it's very, very difficult to figure out the original message. So oftentimes there's not an easy decryption function available to us. So in our code here, let's just say we got rid of this decrypt method. Don't worry about that other method down there. We'll just scoot that out of the way. And let's say we have this message, "You're cute," and I'm just going to get rid of all this other stuff here. So we can encrypt it, and let's see what we get. When we output the encrypted message, we get this, which is exactly what we expected. But if we don't have that decryption algorithm, it's extremely, extremely difficult to reverse that process to get the original input. And that's the magic of encryption. So when you have a more complex encryption algorithm, there are people out there trying to figure out a pattern to basically come up with the decryption algorithm, or to figure out the encrypted version of some of the most common things so that they can kind of piece things together, or whatever it might be. It's an entire science on decrypting stuff. That takes a lot of skill and could be a lot of computational power as well. So with the Caesar cipher, we can see that it's just a shift in characters in code, but that concept is a little bit hard to represent programmatically in code. I mean, I can go up to you and say, hey, check out the secret message. Make sure you just shift all the characters by 5. But that concept's a little challenging to represent in code, and the closest thing to it is a parameterized function. In this situation, we pass in that value 5, and that works as long as the person decrypting it also uses 5. But what if we wanted a more complex algorithm that we could pass in something in here that would change the output altogether? And that is actually made possible thanks to something known as a key. So we know that this 5 is just going to change the algorithm just a little bit by changing how much is shifted. But imagine we had something in here that was totally different, and no matter how we changed it, anytime we changed this, the key, the entire output was completely different. That is the magic of keys and symmetric encryption, which is actually the next topic we're going to be talking about in this little series. This key acts as a digital form of a key used to open a door, but instead of opening a door, you're encoding and decoding a message. So then all I have to do is take this key, hand it to you, make sure no one else sees it, and then we can use that in our correspondence to make sure our messages are secret. So that is the next topic. So if you've enjoyed this or if it was helpful, please be sure to subscribe, as that really helps out the channel. And also, check out the next episode. Now, I've actually partnered with a product here, NordLocker, and this is actually really fitting because they do file encryption, and a lot of these concepts are going to be used. So if you need an application, you can check out NordLocker. Now, to visualize this, you can have a file and you encrypt it using a key. That goes in your locker, which is basically like your files storage. And then when you need to get that file back out, it goes through a decryption process using that same key, and you have the original file. Now, NordLocker is just a little bit different because you're actually going to use a public key and a secret key. We've only talked about secret keys, but we're going to get into public keys and secret keys and the different categories of encryption in the upcoming videos. So be sure to slap that subscribe button and stay tuned. Thank you guys. Peace out.